I would advise it. I would advise a freshman to do research during their freshman year because it's a great experience, and it also shows you the world of physics after you get out of school, what the possibilities of what you can do.
In the research setting, besides really doing something new, you are learning many other things. You are learning to work with your peers, you are learning to work with a professor, you are working with graduate students or postdocs, and working with this variety of people has its own influence on you. I mean, oftentimes they work as role models, oftentimes they challenge you, oftentimes they help you see things that you haven't thought about before.
The key is when you get involved in undergraduate research, you have essentially, experts, that are guiding you along the way, and, they tell you, okay, put your hands on this, move this from here to there. And at first you're very scared because there's so much going on, right? As you do that more and more, you become more and more confident. And this is just all, again, towards that goal of becoming a more independent researcher. And building confidence definitely helps you.
You're around other workers that are in your same situation, and you're both trying to strive to do something, whereas academically you're more at a slow pace doing homework, someone's helping you along, kind of babying you.
The critical thinking process is necessary to break down a problem. We try to teach that in some of our laboratory classes, but those are 2 weeks and you're done. You move on to the next lab. It's not a whole semester where if you don't solve this problem, you can't move on, or you have to work around the problem so that it's not there anymore. Those are things you just don't learn in the classroom.
The very first project I worked on, first day I got into the lab, they told me I was working on this box, which does not sound very exciting, but it really was. The box is used to control the temperature of a laser. I found the box project really fun because it made me stretch my mind. I had to think outside of the box, ironically, to come up with materials to use and ways to install it that weren't normal because I had all these parameters that I had to fit. I loved that it made me think in ways that I hadn't thought before. And
What did I learn besides physics? I would say, you're not just learning the principles of how this works. You're learning how to be a scientist. You're learning how to ask the questions. You're learning how to troubleshoot things when things go wrong. Undergraduate research is really key in getting you started as a young person in that process of developing as a scientist.
the research helps me in ways that I didn't expect. It helps me more in the qualities it's helped me gain, like persistence. It's also helped me look for ways where what I'm learning in the classroom can be applied in research labs. And it's really kind of opened up a lot of my classes to me because they're so much more interesting when you see the real world applications, when you're looking for them instead of just sitting there trying to understand the material.
For physicists, the thing is that they are expected to think outside of the box. They are expected to come up with crazy ideas. And what do you learn to get crazy ideas in research?
We have one student that worked in our research group who, after graduation, moved to a big city, found a job on Craigslist within a few weeks, applied for it, and landed the job. This is a technology company. They were looking for engineers, but when a physicist showed up, they knew enough to hire him. It's important to realize that our undergraduates are qualified for a lot of jobs that may not be advertised to physicists, but there's a general recognition that physicists are problem solvers.
Many of our students got the NSF Graduate Fellowship after graduating based on their research. Many of them are admitted in very high quality, top level graduate schools, again based on their research. 4.0 GPA is not always enough, but if you have published something, you have presented something, you have done something really new, then your chance of getting into these graduate schools is much, much higher.
At Kansas State University, I think we do a very good job of incorporating our undergraduates into research. We have had many students go to national meetings and give presentations on their research. We have also had students win national competitions that are based largely on their scientific research, such as the Goldwater Scholarship. It can really take them far.